Всем привет, меня зовут Сергей.
Hi all, my name is Sergey. I work at VK at the Tarantool team. It has an inbuilt LuaJIT language engine, and we support LuaJIT, a fork of it. Fuzzing is a common tool to test reliability and as a tool for negative testing. We also use it to test functional correctness of compiling. I'll be covering some of the results that we've achieved, and hopefully it'll be interesting for you. In 2022, I did a similar presentation in the high-load section. This presentation builds on my previous one quite naturally. I've covered the entire timeline, highlight some of the success stories, and I've fleshed it out with a bit more detail. I'll be speaking about LuaJIT, how to develop there, what are specifics, and I'll be touching upon some of the social aspects of development. I'll start with a few words about the language, the project that's called LuaJIT. We'll explain some of its internals, not too much detail, but I think it's important to note for you to get a grasp on the context and some idea of the challenges that we faced, meaning that we had some issues to address through fuzzing. So our development on LuaJIT in Tarantool, and I'll wrap it up with concrete tests. A show of hands. Are you familiar with Lua? Have you used it? Well, apart from my colleagues of BK. Well, that's a few of you. It's a light multi-paradigm language. It has two common use scenarios. The first use case is a Lua-only project. It's like a programming language. The more popular use case is where you have a larger product or project and you embed Lua into it as a language to program the business logic. This slide enumerates the projects that rely on Lua. I think you're using it already, actually, in some of the projects or products. It might have been unnoticed by you, but it's there. A few more notes on the language. It doesn't have a specification, but there is documentation that gives you a lot of valuable information, both for the users and for the developers. That's basically the only document to describe the language. We refer to it a lot as we develop our LuaJIT when we seek important answers. Here's a project. You see Real Lua, a reference implementation. It started in 1993 and has been since developed by a team of 3 developers at the University of Rio de Janeiro. It's a proprietary development, but it's available under an open license. The project's own development language is C. I'll be referring to this implementation as Lua. That's what you usually mean by Lua when conversing with your colleagues. I've included the volume of this implementation, just 30,000 lines of code, which is negligibly small compared to other runtime programming languages. LuaJIT is the second most popular implementation. It's a quick interpreter and a tracing JIT compiler. It's been in development since 2005. It's multi-platform. It's a proprietary development, but again, openly available. LuaJIT, when seen as a project, has certain features. I split them into two groups: social features or social attributes. Well, this whole project began with just one developer. That's the maintainer since then and now. His name is Mike Paul, and communicating with him is tricky sometimes. Well, basically, there are no channels to reach out to him, except for the ticket form and the bug taker. So there were cases where people would pick up arguments with him in bug reports, and they got banned. He can also cancel tickets if there is no minimized reproducer for a bug. Another point here. It's a proprietary development, meaning that you have no insight into their plans, the future avenues of development for the project, new features, and so on, which we are used to, well, to be made aware of. The other group that I identify is technical. The first one is that the project doesn't have any regression tests. Again, something common in open source. There is the code, there are regression tests. They are run periodically, night compilations, or pull of requests for patches. LuaJIT doesn't have this. All patches go into the master instance as written by the developer. Then it doesn't have any documentation, which makes it really convenient to use. Next point, lack of clearly readable code. And I don't just mean to say that it's complex. It lacks some things that you get used to having worked on other projects. It has single character variables, so it's not as readable. The indents are not uniform, it's just not as readable, which led to forks being created from LuaJIT. Tarantool, OpenResty, Luavella, others. Curiously, the maintainers of these forks do not cooperate. These are, well, self-sufficient entities that live independently. Now I'm going to give you a brief description of LuaJIT. What's under the hood. It's not exhaustive, but these are some highlights that are important for my presentation. We have Lua code. We run it in LuaJIT. It goes to the lexical analyzer. The code is tokenized. They are analyzed for syntax. The analyzer identifies syntactical structures. It's converted into the bytecode, which goes to the interpreter. You can feed bytecode from the beginning. It will go through its appropriate front end and get to the interpreter. If there are bits of code that need to run frequently, LuaJIT traces them, these most popular areas of code, so to speak. Once it's identified, LuaJIT records this trace or route, and it's translated into IRs, intermediate representation. It's optimized and then assembled. Downstream of which you have machine code to be executed. Once you have this trace route, once it's assembled, it goes back to the interpreter, and it fetches the bytecode so that execution is done through this pre-recorded trace or route. There are libraries to supplement it: JIT compiler, standard library, FFI to get integrated with C, and some extensions. So there is the VM, the compiler, and this other bit that's responsible for C integration. We'll focus on the interpreter today, the standard libraries, and the JIT compiler.
LuaJIT интерпретатор. Что в нем есть интересного?
Let's start with the interpreter.
Интерпретатор для обычного...
What can this look like for any run-of-the-mill programming language? It's a switch structure that processes each of the bytecodes and executes it.
Как это реализовано в LuaJIT?
In Lua,
Вот такое вот описание для
we
каждого
have this description for each of the bytecode strings. It's BC code that concatenates two lines.
Есть такое описание.
For each of the bytecodes, there is a description like this.
Позже транслируется такой штукой,
It's then translated into
которая преобразует
DIN-ASM, DIN-ASM, that converts the macro assembler into code
В чем преимущество вот такого вот
to be
странного?
generated.
В том, что у нас
This description is a bit off, it's weird, but the upside is that you can combine or merge
и можно использовать
C-based structures, assembler macros, and you can use addresses,
обращение к C-шным структурам без разименования,
requests
указателей и
to C structures without offsets or renaming.
трансляция вот это вот описание для каждого байткода.
Once the description translation has been done, DIN-ASM translates this into C code, and it gets converted into
стандартной библиотеки.
binary code.
Как я уже сказал,
Then standard libraries.
встроенные функции, стандартную
It
библиотеку
has some built-in functions,
работы со строками, таблицами для
working with strings, tables,
математические функции.
interfacing with the OS, maths functions,
Стандартные библиотеки для скриптового языка программирования.
the usual deal for any script language,
Для управления
LuaJIT FFI,
компилятором.
and the compiler library.
Как бы любая реализация может содержать
Any implementation
быстрый путь исполнения, fast,
can contain
более долгий путь,
the fast path
обработка ошибок. Как это сделать?
and
Как
a
сделать
slower path
в
that
стандартной библиотеке?
does processing of errors as well.
Слева у нас представлена реализация,
In the standard library,
преобразует строку в число.
for example, to the left we have toNumber, the function that converts a line into a digit, a number.
Если исполнение пошло не по быстрому пути,
If something goes wrong,
в C-шную реализацию, которая как раз
it falls back onto C.
исправление и содержит
It's a longer path
всех ошибок. Вот в этом
that treats the errors as well. The example
который обрабатывает ошибки.
has a fallback into lines
Давайте теперь посмотрим на JIT-компилятор.
to deal with errors. Next, the JIT compiler.
Я рассказывал про виртуальную машину. Допустим,
I
виртуальная
told you about the VM.
которая последовательно
Let's say it has several sections of code to be run in sequence, and there is a sequence that's hot, meaning that it gets executed more often than the others. JIT compiler records this as a root, and
скомпилированную трассу.
control is handed over to a compiled trace or root.
Любой кусочек байткода может быть записан, а только
You cannot record any bits of bytecodes,
в LuaJIT это
just some specific instructions.
для разных
In LuaJIT,
функций и циклов.
these are instructions for different functions and cycles.
Код инструкции в LuaJIT поддерживается
Each such bytecode instruction
таблица со счетчиком,
is supported with a hash table.
модифицируется. При достижении
Each
счетчика
time it's run, the counter ticks.
начинается запись трассы.
If it goes down to 0,
Или трассировка
the trace is recorded. Here is how tracing works. Here is the code to assign a variable. It's a number. Then there is a condition. Is it a number or not? If it is, then we go to this one branch. Then we need to know if it's positive or negative. Another condition, just one branch out of two. This execution path has some limitations, just by nature of the path. And each such fork or decision is called a guard. That's what LuaJIT records. The guards, as they're called, are needed so that we record and save this route. If it's deviated, the execution continues in the interpreter. LuaJIT offers this functionality to switch over execution from the compiler back to the interpreter, meaning that it supports visualization of process slots in a visual processor. But why do we need these IRs? Here is a code that adds values. The bytecode for this looks like this. Doesn't have enough layers. The IR looks like this. As you see, the code is enriched with data types and other supplementary information. It gives compiler more information to work on. This allows the compiler to optimize the code before compiling to make it run more efficiently. By optimization here, we mean that the code is transformed without any changes to its semantics. Pure efficiency. Why would you need all this complexity? An interpreter with the assembler, recording of traces, compiler. Let's look at it with an example. It has a list of 5 values. It multiplies to the power of 2, and this structure translates into an assembly code of 10 instructions. LuaJIT violates the dry principle, which states that you shouldn't duplicate entities where it's not needed. One such violation was just described, this fast function that work in the interpreter. Then there is bypassing of tables, indexing of tables, bytecode lister, and this specific function JTemp. It's implemented in C, as well as in the Lua section. Not going to deep dive into this. It's one of the complex features. Alton Soldatov has made a great presentation on this, where he lays it all out. So, comes highly recommended. That's it for the language's internals. There are 2 great presentations on this with more detail. Slava Yegorov, our former colleague, Maxim Kakrashkin, and Podlotka podcast addressed this as well. Anton Soldatov discussed the language, LuaJIT as a project, and other interesting things. But that's not all. There are other well-known challenges with LuaJIT. Well known. Here they are on just one slide, easily available for your information. But we had to discover them as we explored LuaJIT. Nobody told us this. Nobody warned us about this. We had to learn it from experience as we were doing fuzzing. We faced each of those as a problem. We were looking for solutions. But first, what about there? Dirty reads with lines, you have to suppress it with sanitizer. LuaJIT has some persistent bugs with uncertain behaviors in part of C. Sometimes you encounter unexpected effects when you do not use your lights properly.
LuaJIT реализован с помощью низкоуровневых языков программирования, ассемблера и C. У него разная реализация.
And it has different implementations for low-level interpreter when it comes to different platforms. It violates the DRI principle, since it has two modes of operation. You have to double-check the code for both the interpreter and the compiler. And you need to be careful with your transitions between those two. There are different ways to optimize in the interpreter and the compiler. So again, you have to check the correct execution of your code when such optimizations are applied. There are well-known problems still to be fixed, and then we have two APIs for testing. Let's speak about our own project, Tarantool, and how we're using LuaJIT. We've had some issues with LuaJIT support in Tarantool because we had many crashes in production because of LuaJIT's bad behavior. It wasn't easy to investigate. Well, if you've dealt with it once in any context, you'd know. An unknown environment, some code that you didn't write, it crashes. It's really hard to understand what's going on just through the shell. So it comes with a host of issues, and some challenges were hard to remedy, and we were pretty helpless against the complaints of the users. We couldn't find a fix. So we became anxious when we added any changes to our fork, because nobody would guarantee that these changes would not break some other components and wouldn't make LuaJIT even worse. Backporting of patches was a challenge as well. We ran a fork, so we tried to synchronize with upstream vanilla. If they come up with something interesting, we try to borrow it. But backporting was a pain. LuaJIT doesn't have tests. You just add the patch and close the ticket. So the patches could be incomplete. They could be just have bait fixes, or they could introduce regressions in other areas of the code. And then our relationship with the maintainer was quite strained. At some point, he messaged us that he'd never want to hear from us again. We've tried to improve this on our own. We've aggregated all tests that we could find. We aggregated it into a repository, and we now have 76% line-by-line coverage. That took a lot of effort. Next, we started backporting patches with more care. And we came up with a rule for this. Any line that is changed by a patch or added by a patch has to be covered with a backtest. It's not easy to do because some patches are tricky and you will struggle to come up with tests. And there is more hassle with them than value. As for bug fixes, we started using the upstream first approach. Any issue we would come up with, we will come against. We'd report it upstream, wait for a fix, and then, and only then, we'd install the patch. Huge effort of many years, but it was still not enough, unfortunately. We still had crashes in production. So we decided to fuzz it.
С точки зрения дизайна,
And here I go on to tests.
было решено построить тесты
In
следующим
terms of
образом.
test design, we decided to structure the test to first cover the APIs that we have in LuaJIT,
Другие тесты
and then be supplemented with additional tests
как я уже говорил,
to check input data. You can pass Lua code or bytecode to it,
отвлекусь от самих
as I've mentioned.
тестов, расскажу для контекста.
Let me digress for a bit to give you a bit more context.
У нас есть пример кода.
This is Lua API and C API.
Нам нужно сложить
To get 300,
два числа 100 и 200.
we need to add 100 to 200, and then you assign
Чтобы сделать то же самое,
this as a variable foo. One line of code in Lua, but in C API, you need 4 functions,
все API работают с так называемым Lua
all of
stack.
which work with Lua stack.
Взаимодействие между этими функциями строится через стек.
All interactions between functions go through this
Нам сложить два числа,
stack
нам нужно положить
structure.
на стек 100, положить на стек,
So you
положить на стек число
put in
200,
100,
дальше вызвать функцию
200,
сложения
you call
двух элементов,
the
которые лежат на стеке.
summation function
Потом мы
of these two elements that are already in the
у
stack.
нас на стеке появится результат этого вычисления. И
You
дальше
get the
мы
result returned to the stack as well, and you call Lua set global. It takes the topmost element in the stack and assigns it to the for variable.
любая вот эта функция, которая составляет
Any such function
API, она содержит в себе
that's part of C API
так называемый
also contains function indicators.
Есть
Function indicators
числа.
pretty much do this.
Поведение.
There are
Первое число
3 numbers
описывает, сколько элементов функция
that describe the function's behavior. The first one says how many elements it'll take from the stack. The second number will set the number of elements to be added after the function has run. And the third number indicates if it'll drop any exceptions. It's in the manual, and this indicator is helpful to check the correctness of behavior of functions in C API. You might have heard about design by contract, or hars, thirds. That's pretty much the same or similar. This can be used as a test oracle to check for correctness. Here is the test itself. We call random functions, we pass random arguments to them, and we see if this indicator is executable. The reference implementation of Lua supports 90% coverage of the entire implementation in C API, so the rate of code reuse is very high. It's not possible with LuaJIT, so we had to add some more tests. Now on to Lua API. LuaJIT doesn't have that many functions, actually, especially if compared to Python. It's around 200. We have a shell for each of the functions. We call it, and we pass random inputs to it.
It is not for all the functions that we managed to do that. For mathematical functions, it's easy. We can check commutativity on other functions which you know from mathematics, which work with lines or tables. Such checks are more difficult. So we wrote for each function some wrappings and used native fuzzing for Lua. I made a presentation about that fuzzer in 2022. We improved it since then. What can I say now? This fuzzing is for Lua and native expansions for C. For the feedback, it uses the tools of C because actually it's used for fuzzer, and in runtime it uses the standard Lua library. Lua has been included in the crusher some time ago, which was developed by the Russian Academy of Science, and we want to expand the usage of that fuzzer. Let's look at the diagram for LuaJIT. Let me remind you that the virtual machine can have data in two formats, Lua code and ready-made byte code. We tested it, assuming that any correct Lua code can be executed in LuaJIT, including the byte code. To test it from the viewpoint of the code, we developed a generator of programs, and the reference includes format of Lua language. We took the grammar, tested it in the buffer protocol. We created C executor and made a test for leafizer. And the diagram is as follows. We have a grammar described in buffers protocol. From that grammar, we generate a scheme with the help of serializer. We use it and give it to for execution, and we don't see any anomalies, no crashes, no hangings. Everything seemed to be good. Then we decided to see how efficient is the test. We looked at the coverage of the code. The coverage was not very big. Then we looked at whether we have any errors from syntax analyzer during the running of the code. And we saw syntax errors. We looked at LuaJIT metrics to see how much of the generated code goes to the compiler. Syntax errors were numerous, so the implementer was not quite correct. The most popular error was that the break and return operators were added at random. In low reference manual, they can be put only at the end of the block. We corrected the errors. Another class of errors was semantic. In Lua, we generated some objects, and we could use some operations, and those data types didn't support such operations. The interpreter had an error and stopped running the program. And often we had timeouts because of recursive calls or cycles. How did we solve that problem? Timeout was easy. We added the counters, which were initialized at the end of cycle, and if they reached a certain level, we ended the cycle. When I told you about tracing, cycles are one of the parts of the code when the compiler can turn into a track, when we don't want cycles. So we left 5 here for the code, sometimes to be compiled, but without cycling. changes of semantics. So we could generate this code, which added two Boolean variables. There is no sense in doing that. In Lua, there are meta tables which help you to support some operations for objects and data types. For Boolean variables, we had a meta table which could avoid errors when we add two Boolean variables. Testing of BC front end. Bytecode execution shouldn't lead to any problems in LuaJIT. We couldn't send the randomly generated code. It's so written that we may have some data memory leaks. So we cannot send garbage. How can we test bytecode here? And we found the solution. We have a Lua code generator, which generates code, and we give LuaDAM function there, and we have a bytecode at the end, and then we execute that bytecode. All those tests were integrated into the development process. We integrated it in our development process and in Google, which also helps us to test a lot of components. And with the help of fuzzing tests, we can find a lot of bugs. With LuaJIT, we couldn't do that, and we used cluster fuzz as a result. We test different areas. Sometimes we are not waiting for someone to make regression, and in several years we're going to find it, and a certain user will raise alarm. We do it in advance to find bugs as soon as possible, develop patches, and do stable vanilla version and production version. This infrastructure, cluster fuzz, helps us to automate routine, and we can have automatic ticketing with appropriate vertical elimination of bugs. When the patch gets into the project, we launch fuzzing, and if the problem is not reproduced, then the ticket is automatically closed. One more thing is minimization of test cases. I described the tests which were developed, but LuaJIT is a complex component, and some parts of it are covered in a good way, and some are covered insufficiently, and we need some more tests which would be more focused, which are not covered in the right way today. There are some problems with code instrumentation, the code which was written in assembler. If we use the fuzzer, the code is instrumented and we have feedback. But if the code is written in assembler, we lack the feedback, and we don't understand how efficient we run the fuzzing. And actually, what we have is brute force. There are some ideas what to do next, but these are only plans. What are the results? The main result, which we wanted to have, a reduction of the number of incidents, reuse of tests, a common Lua API helped us to use the same fuzzing for different stages of development. We try to test the product as early as possible. As an example, I can tell you that on Sunday, I ran some codes, and I had a mail saying that in Lua, they found a new problem. Of course, I stopped preparing my presentation. I wanted to minimize the test case. I looked at the bug and also when was the problem detected. Commit was carried out 3 days ago. So 3 days in such a mode when the development is closed and commit from the internal repository goes to GitHub, 3 days is not a bad result. We reached good coverage in LuaJIT 61%. If you use all the tests, then we can cover up to 90% of the lines. And finally, these are all the problems that we found through fuzzing categories of the problems. In LuaJIT, we found more problems, 26 in LuaJIT and 6 in reference implementation. And a reachable assertion category gave us most of the problems because the authors who generated the code actively use assertions, defending programming style. And it's easier as a result to find anomalies in the code. All the projects are here. Everything is freely available. GitHub, the code, and the fuzzer for Lua. You can download, you can read, you can ask your questions. Thank you for attention. Now it's time for questions and answers. This is the QR code where you can not only vote for my presentation. Of course, I will be happy if you evaluate it highly, but you can also provide me with your feedback, any comments, anything. You are welcome. I have several questions. The first one, you said that you expressed Lua grammar through proto-buffers. Could you express the entire grammar, or are there any limitations there? Initially, we developed this test for LuaJIT. In one of the first slides, I told you that LuaJIT is more or less equal to Lua 5.1. The current version is 5.4. In reference implementation, we have some new things in the grammar. For LuaJIT, we cover the entire grammar, but as for the latest version, not everything, because there are some new things there which were not covered. I wanted to eliminate that drawback, but I didn't manage to do it yet. It's not about the entire coverage. Buffers are not quite good for grammar because the grammar is different there. So did you express all the grammar of Lua? Yes, we did. That's interesting. Second question, if I got you correctly, for C everything is all right, for Lua also okay, but with Lua it's interesting.
Я попробую коротко описать, рассказать.
Let me try to tell you briefly. The first implementation contained feedback which worked through hooks, which worked for each and every new line that was run and executed.
Реализацию фазинга для других средств.
If we looked at implementation for other languages, like JavaScript, Traizer, Eteris,
Они сделали вот эту инструментацию для самого
they
языка
did it
более эффективной за счет того, что они
more efficiently because they instrumented not the code, but the bytecode.
Lua, там достаточно компактная реализация, и вот этого
We have a compact implementation,
недостаточно для того, чтобы
and the hook that works line by line is not enough for efficient implementation. I wrote in Spring how instrumentation was done in fuzzers for other languages and how we can do it for Lua. Unfortunately, I didn't see any positive reaction from developers, but actually we decided not to stop at this point, although we didn't see any positive response from those who develop reference implementation. We have an idea how to make it more efficient. We want to take bytecode, which is executed in Lua, and implement it, but we haven't done it yet. Briefly, yes, now it's not very efficient for Lua, but we are going to correct it in the near future. And what about the current implementation? How slow does the fuzzing become? How large is the slowdown? The slowdown is big.
если использовать хуки в Lua,
If we use hooks in Lua, well, execution is slowed down. Each line requires certain action. Then you go to the next line. I cannot tell you about percentage points, but it's obvious. But can you measure it and tell the developers that this problem will be... Well, fuzzing is not the problem they are going to solve right now.
не знаю. Посмотрим.
I don't know. Let's wait and see. Let's see what we can invent to raise efficiency. During the presentation, you told us a lot about interaction with the community. One developer was against, then he was thankful. I didn't understand what about upstream first. If relations are bad, then how can you correct the bugs in the upstream? I don't see any contradiction here. It's a standard practice. When you have fork, you develop it, but at the same time, you don't want to lose the time with the link to the parent version. Between vanilla version and your fork. You first go to upstream, wait for the patch, which is agreed upon with the developer of the parent version, and then use it. Yeah, I have a lot of examples of different projects when we worked in a different way and had a lot of overhead. I can provide you with examples. because now we have limited time. The approach is understandable. The question is about interaction, about complex interaction, that your problems are not interesting to him, and how you interact with that person then.
Ну, автор, мейнтейнер LuaJIT тоже заинтересован на самом деле в том, чтобы проблемы...
Well, they are interested in eliminating all the problems. If the problem is confirmed, then he is interested in its elimination. He doesn't want to do the routine work.
Какую-то версию, например, своего луашного модуля, да, и сказать, что вот...
If a person can say, if I run it this way, then LuaJIT works incorrectly. It's not an easy kind of work. It is not interesting. He wants new codes, new features, new functions. He wants code which can reproduce the problem. And then the next question, you had slides about automation, cluster, fuzzing. Do the reports go through you or directly? You process it and then you enter it manually
Ну, вот этот весь процесс...
into, well,
который принят в проекте OSFAS, он на самом
the
деле...
process is well documented. Briefly, the scheme is like this. We have open code of fuzzing tests that we run in the infrastructure. There are description files, and these tests periodically are collected, run in Google, and if there is a certain anomaly, something goes wrong. Assertion worked, or ASAN, DBSAN led to some falses, then we automatically generate a ticket. But those who support tests, they have access to those tickets. For Tarantool, for native Lua, there is a ticket, you get a mail, and then you try to find out, is it a false positive or is it a true positive? You have to minimize, do something about it. Well, I see. And the final question, if you have different implementations, C, Lua, plus something else, LuaJIT, and the main Lua, did you try, apart from fuzzing and typical bugs, assertions, memory corruption, did you try to compare those differential fuzzing? No, we didn't do it yet. We have it in our plans. I didn't show it in my slides, but this is one of the things that we want to implement. So we are thinking about how to do it right now. Thank you.
Сергей, привет еще раз. Спасибо за интересный...
Sergey, hi again. Thank you for the presentation. I have a question. JITOM and Lua are far from me. I do with eBPF, and I think the problems are similar. In eBPF, we actively fuzz the verifier, and it looks as if we use similar approaches. Bytecodes which are JITted, and there are a lot of fuzzers there. Google makes some of them and other developers. Did you look at them, how they generate such programs? Maybe it could be useful to you, and maybe you can use some of their approaches. I continuously do that. Any article about successes in fuzzing, compilers, interpreters, well, I try to read. Try to read and find something that could be useful to me that I could reuse in our environment. I don't know if I know fuzzing is there. If you prompt some resources to me where I can read about them, I will be happy. Yes, I can show you reports and presentations. That might be interesting. Thank you. Then, at this point, I would like you to choose the best question. I would have listened to the... Oh, there is one more question, the last question. Well, maybe I am not a very experienced fuzzer, but in Lua and LuaJIT, I have just been certified. We certified our solution and Jinx with its scripts. Lua and LuaJIT are there, and I didn't understand why LuaJIT at all. Lua is faster, simpler, and more reliable, as far as I am concerned. You mean implementation? Faster? I doubt it. LuaJIT used tracing compiler. It can do the reference implementation. Maybe our tests were small, so I didn't feel that. I looked performance of the fuzzer per second. Maybe I'm wrong. I would like to ask you, you said about code generation. Is Lua compatible to different... Well, bytecode is not compatible between different implementations, between the reference, Lua, and... We have 5 formats of bytecodes. I would like to add that that I told you how we tested, what I did to test the bytecode. I took test scripts from Lua and the scripts in Jinx. About 350 scripts I had in Lua and LuaC. We have coverage with standard compiler was about 64%, and LuaJIT less than that, about 47, if I'm not mistaken. I think it doesn't match what you say. Perhaps the code was cleaned beforehand. Perhaps. Well, we develop Tarantool, and we have a lot of tests for Tarantool. All of them are written in Lua. For each patch, each request, we run a set of tests. In LuaJIT, we didn't have any problems. We have regress models, and we didn't find any problems. But when we started fuzzing, we found 26 crashes. Proceeding from that, do you think fuzzing is relevant? Coverage is coverage, but if you have few tests for compiler, you wouldn't find the problems, you will miss them. Okay, the coverage is good, but we need more than that. We found serious results by developing regression tests,
We've been able to achieve results,
but
as we developed the regression kit for
stability
our
and
fork,
reliability
it still didn't give
of
us the
LuaJIT
reliability that we
didn't
wanted.
reach. But with fuzzing, we did that.
That we were only able to achieve through eliminating crashes that bothered our users through fuzzing. So yeah, I believe that our efforts were not in vain. There is this crash in 5 point 1, 2 to some special characters, 2 or 3 of them, that come before the space. Was an exception. Apparently, that's during syntactical or lexical analysis, as it was just trying to start executing the script. That's where it crashed. In DynamoRes, did you find this? It's not that the code is incorrect. Well, I'm not sure if it's something that we've seen based on your oral description. There is sfuzz. It integrates with different open source components. The Institute of Systemic Programming has a product for dynamic analysis, an analog of OSFAS, CITRFAS, it's called, can be integrated into open source projects to fuzz them with their proprietary closed code solution. We integrated Tarantool and our fork of LuaJIT into that. We updated it recently. They ran it on LuaJIT vanilla and sent me a huge pile of logs where there were alerts. But they were all false positives, because mostly this was due to errors in bytecode. That triggered LuaJIT and it crashed. It's a well-known issue. The parser is quite touchy there, and it crashes with improperly formed bytecode. The maintainer just doesn't want to rectify it. You might be speaking about a false positive, but maybe not. We can take this offline if you wish. Here at the conference, you can minimize it if it's a real bug, and let's send the ticket together. I can try and replicate it at a different machine. Don't have access to the results anymore because I've switched to jobs. But thank you for the conversation. I hate to jump in. While Sergey is selecting the best question, I invite you to scan the code, rate Sergey's presentation, only good comments, and you'll be entered into the poll for a great book from Roman. Okay, so what was the best question? The first one. Very many, very different questions. I'm not sure which one, but that's just one guy, so yeah, that one. Please come up. I see your radiant smile again. Thank you all.